We are going to solve an equation that has like terms that need to be combined on both the left hand and the right hand side of the equal sign. When we solve an equation, we typically start with the distributive property, so that's what we're going to do here as well. So we have this 3, and we're going to distribute it to the x and also to the negative 5. On the left hand side, I'm going to just rewrite, so 9 plus 2x minus 7 is equal to 3x minus 15 plus 17. We can simplify even further because the 9 and the negative 7 are like terms, both constant terms. So 9 minus 7 is 2, so I have 2 plus 2x. On the other side of my equation, I have a similar situation. This negative 15 and the 17 are like terms, so I can combine them together, and I have 3x, and then negative 15 plus 17 is plus 2. Now, I have x terms on both sides of my equation. I usually find it most helpful to pull them together. And so in this case, I'm going to subtract 2x from both sides. And so on the left-hand side, these terms cancel, and so I have 2 equals. On the right-hand side, 3 minus 2 is simply 1x. We don't have to write the 1 in algebra. And then I have a plus 2. So now my x terms are all collected, and I want to get my constant terms together, so I will subtract 2 from both the left and the right. 2 minus 2 is 0. I do have to write that 0 because I need a placeholder on the left side of my equation. And on the right hand side, 2 minus 2 is 0, and so I have x equals 0. Now there is a temptation to think that this means that there's no solution or that there's all real numbers, but that's not the case. The actual answer is that 0 solves this equation. If I would go back to the original problem and substitute 0 for x, I can see that I would have 9 minus 7, which is 2 on the left-hand side. And on the right-hand side, I would have 3 times negative 5, so negative 15 plus 17, which is also 2. So I have one solution, x equals 0.